lesson 10.2, finding arc measures, part 2. Okay, congruent circles theorem says two circles are congruent if and only if, remember IFF is if and only if, they have the same radius. And the if and only if always means that it can go both ways. So if you know two circles are congruent, you know they have the same radius. If you know two circles have the same radius, then you know they're congruent. Okay? All right. Congruent central angles theorem. Congruent central angles theorem says two minor arcs are congruent if and only if their corresponding central angles are congruent. Okay, so let's look at a picture of that. So we have our circle, here's our center. Okay, we have C, B, D, E, middle's A, and we can say that BC, arc BC, is congruent to arc DE if and only if angle BAC, the central angle, is congruent to angle DAE. Okay, so again, it can go both ways. If you know the two arcs are congruent to each other, you can assume the two central angles are congruent. If you know the two central angles are congruent, you can assume the two arcs are congruent. Now in this case, these are vertical angles, so we know for sure they have to be congruent, which means the two arcs have to be congruent too. Okay. Now I want to show you something that a lot of people mess up on. If you, I'm gonna leave that there. If you have a larger circle and then a smaller circle inside of it, so concentric, right? They share the same center, which is Q, and we have this. Okay, now I want you to look at that. So we have R and S on the little circle. We have T and U on the bigger circle. They both are formed by these same radii, right? And we can see it's a 90-degree angle. Therefore, arc RS and arc TU have the same arc measure in degrees, right? Because we know if we're just looking at the little inner circle, this arc is has a central angle of 90 degrees. So arc RS has a 90-degree measure. Arc TU also has that same central angle. So it also has a 90-degree measure. Okay, here's where people get messed up though, and we're gonna do this in a couple more lessons, is if you were actually finding the length of TDU, not its degree measure, but how long it is. Obviously you can see that TU would be longer than RS. That's called arc length, okay? So you just gotta, and again, we'll get to it in a few lessons, but you gotta keep those two things separate. So this is the measure of arc RS, that's gonna be 90 degrees. The measure of arc TU, also 90 degrees, okay? But their actual length is not congruent. And I'm going to show you how to find arc length. It's based on the circumference, right? Arc measure is in degrees and based on the central angle. Arc length depends on the circumference. So because those two circles have different circumference lengths, their arc lengths can't then be the same. Okay. Okay, so if we have A and B, and C and D, the measure of arc AB has to equal the measure of arc CD, right? They're both 145 degrees. Now, here's where, let's see, I didn't mark this. So from the center to B is congruent from the center to C. So when you see that, if the radius is the same, what do we know? Those two circles are congruent to each other. They have the same radius length, so they have to be the exact same dimensions. Then you can say, well, then the arc length would also be the same, right? Because the circumference is going to then be the same as well. Okay, so as long as the circles are congruent, then the arc length will also be the same. Is congruent because the radius is congruent. Okay, so quick note, if the circles are not congruent, then the arc length, not its measure, but the arc length would not be congruent. Okay, we're going to use the rest of the page for this next thing because I need you to remember this. The similar circles theorem. Everybody ready? All circles are similar. They aren't all congruent, but they are all similar. I'm almost positive I saw a question last year about that. So just please remember, all circles are similar, Okay, they're not all congruent, but they're all similar. That's it.